Hi everyone, welcome back. Now today I want to share with you a bit more about this function. Now there is often people confuse functions as something like what we consider as go-to. Yeah. So let's say for example I have a function A, take in two variable, okay, variable A and variable B for instance. Then I'm going to return maybe variable b plus variable a, this kind of function call. Now when I want to invoke the function, we will call it this way. You put in your two value inside. Now many people thought that this is actually some sort like a go-to thing. It's like when you start your program from top to bottom, where of course this function will not be triggered. Okay, it's some sort like a declaration. Now it will be only triggered here, so you can say that console log program starts, okay, and then you can have like program ends. So you can keep on add lots of code here. And when people reaches this point, people have if it is a misconception that you think that this guy actually travel all the way here, go in, get this thing done, return the value and come back here. Okay, if you think of it that way, then this is not it's going to be difficult for you to understand a recursion. So if I think as we have mentioned in the class, so this function A is not some sort of like a go-to function, but rather it creates an instance of this. So in other words, if you happen to have another V function call, yeah, although they are identical, but they are actually two different kind of two different code, although they are identical. So you can imagine that they are actually two different instances. Yeah, two different instances. Now why this is important. Now some of you said that, hey, this one come inside if I call these functions, I come inside here, get this thing done, come back, return the result, and this one I repeat the same thing again. It seems like it is okay. Yeah, it seems like this way of thinking it has not does not have much problem. But in actual fact, if this is a recursion function, then the idea of thinking that this guy will actually come here and trigger this function and then goes into continue again, it will be pretty confusing. So let me give you an example. Let me give you an example of for kind of like recursion. Like let's look at this function. All right, let's look at this function. Okay. Okay, what will happen if I do this? Inside here, I call function A as well. Now this is a bit interesting because you will be entering some sort like an infinite calling. This guy will call this guy, and then we'll return again, and this guy will call this guy. Just keep on calling this guy. Yeah. So if you see carefully, why I won't suggest that this is like a go-to, because if you use a go-to kind of thinking, you won't be able to imagine this. So in order to imagine this, you think of this is actually one copy of this. So when it's called, it creates another whole copy which looks exactly the same, and it triggers again. So in other words, this will trigger in a way that is infinite. So what we need to do here is we want them to trigger it this way, but we want it to have a eventual kind of stopping point. Yeah, eventually we want them to stop. So this is what we call like a recursion. Okay, this is what we call a recursion. So we say that if b equals to 0, then return 1, for example. Yeah, else continue calling this one, but your b, you minus 1. So you keep on minus 1 so that you come in here and then you start to call again. All right. Now this will eventually stop, because as long as your b is larger than 0, it will keep on become smaller and smaller, right? Smaller and smaller. In this case, let me do a favor. I'll put a minus at the front, yeah, so that the number is actually smaller. To be on the safe side, you can put it like that, -1. Okay, so if you put a 5 here for the first time, it will become a 4 kind of copy, then 3, 2, 1 until 0, then you will just return 1. Okay, return 1. So what can we do with this? What can we do with this? This is something like what we call a recursion. So let me try to call this function and see if it's okay with JavaScript. Yeah, so you can see it is working. Okay, it is working. So what can we do here is that we can kind of like emulate something like, you know, recursion, something like a recursion. So let me try to do a console dot log here. Let me put in the B here. You can see I have this 5, 4, 3, 2, 1. How do I get this 5, 4, 3, 2, 1? Okay, if you see carefully, I will first put in the 5. So if it's not equal to 0, then it will display 5. This is where you see it. And then -1 become 4. Enter the function, create another copy of this, but this time the B is 4. So, you know, then you display the 4 and 4 minus 1, create another copy of this function, another instance of it, but this time the B is 3. So it keeps on doing this until the B is 0. Now, interestingly, if you take this console and put it at the bottom, you can see now it's 5, 4, 3, 2, 1. If I run again, you get to see 1, 2, 3, 4, 5. Now, how this actually works is because every time when you call this function, it will not be triggering this one yet, because this function is not completed until the B equals to 0 and it starts to return. Now what you're looking at is a recursion. Okay, a recursion. What I want to show you this is to let you know that though we are not supposed to have the same function calling itself, but if you were to do that in computer science, we call it recursion, and you need to make sure that the cases for each call will eventually converge to this what we call the sentinel case, yeah, so that it will stop calling it. Now this recursion approach is you know, in terms of performance, it is not very effective or efficient, I would say, but one of the good thing about it is that, you know, you can write code, yeah, with fairly simple or little codes, yeah, and it's easy to understand. Alright, so that's all for this recursion chapter. I hope you guys like it. I'll see you guys in next video.